Hello and welcome. आज की इस विश्लेषण में we're going to unpack something absolutely monumental, a text that literally changed our entire understanding of the universe. I want you to just imagine for a second, looking up at the night sky, centuries before telescopes, computers, or modern observatories were even a thought, and still being able to perfectly calculate the movements of the cosmos. Sounds impossible, right? Well, that's exactly what the ancient Indian text, the Surya Siddhanta, achieved. It's truly a foundational text of early science, and today we're going to break down exactly how it works.
When we think about ancient texts, it's super easy to just assume they're all based on philosophy or mythology, maybe just some abstract observation. But the Surya Siddhanta, it completely breaks that mold. So the crucial point is, this wasn't just people looking at the stars and wondering what they meant. No, this was rigorous, systematic science. We're talking about a foundation built on exact calculations, testable predictions, and mathematical proofs that actually laid the groundwork for modern astronomy.
Get this. The text contains over 500 incredibly complex mathematical and astronomical formulas. But here's the truly mind-blowing part. They aren't written out in dry, boring equations like you'd see in a modern textbook. Nope. Every single one of these formulas is written completely in rhythmic poetic meter, known in Sanskrit as shlokas. It's just wild to think about. They literally merge the highest levels of hard mathematics with the beautiful rhythmic flow of poetry.
And if how it was recorded doesn't amaze you, consider the timeline. This body of knowledge spans over 1,600 years. Think about that for a second. For over a millennium and a half, the mathematical truths locked inside these poetic verses have survived. They've gone on to influence countless generations of thinkers, mathematicians, and astronomers all over the globe.
Okay, let's dive into this. Here is the roadmap for our explainer today. We'll trace the scientific rise of ancient India, decode the universe and planetary motion, explore the precise math and astronomical tools used, follow the epic historical journey of this knowledge, and finally, look at its immortal legacy and modern use.
Section 1. The Scientific Rise of Ancient India, the Golden Origin.
So, the Surya Siddhanta was composed roughly around 400 to 500 CE, right in the heart of the Gupta period. Historians actually often refer to the Gupta period as the scientific golden age of ancient India, and honestly, texts like this are exactly why. Spanning 14 comprehensive chapters, it was written entirely in Sanskrit, and it belongs to the broader Siddhanta tradition, which is basically a lineage of texts deeply focused on scientific and mathematical astronomy, rather than just casual stargazing.
Back in the ancient world, understanding the heavens was usually limited to darshan, philosophy and abstract thought. But the Siddhanta tradition, championed by the Surya Siddhanta, shifted the paradigm entirely toward vyavasthit vigyan, systematic science. It demanded actual mathematical and astronomical proof for heavenly phenomena. This wasn't just a small step forward, it was an absolute revolution in human thought.
Section 2. Universe and planetary motion, decoding the heavens. Let's move to and see how this builds.
The sheer breadth of topics they calculated within these 14 chapters is just remarkable. They mapped exact timekeeping, everything from your daily sunrise and sunset to massive cosmic epochs known as yugas. They tracked the orbits, speeds, and positions of 7 planets using advanced trigonometry. They even developed formulas to precisely predict both solar and lunar eclipses and catalog the exact positions of 27 specific constellations known as nakshatras. It was literally a complete, functioning mathematical model of the cosmos.
But wait, out of all that data, there's one detail that absolutely blows my mind. Hidden right there within the verses of the Surya Siddhanta is the radical hint of a sun-centric or heliocentric planetary system. Yes! Centuries before this concept was even accepted in the Western world, ancient Indian astronomers were already mathematically exploring the idea that the sun, not the Earth, was the central anchor of our entire planetary system. How amazing is that?
Section 3. Math and Precise Astronomical Tools, the Math Behind the Magic.
Now, what's really interesting about this slide is that we are essentially looking at the direct ancestors of the math you probably struggled with in high school. To map the curved movements of planets across the sky, you need way more than just basic arithmetic, right? You need trigonometry. The Surya Siddhanta used extensive tables of ja and koja. Those are the ancient Sanskrit terms for the foundational trigonometric functions we know as sine and cosine. They used these exact functions to calculate the intricate shifting positions of celestial bodies.
But hey, it wasn't just math on a piece of paper. The math had to meet the physical world to actually be proven. The text details specific physical measuring devices that they used to track these calculations in real life. They used the Goliantra, which was a complex spherical instrument designed to physically model the celestial spheres, and the Shenku, a highly precise sundial or gnomon. So these physical tools were used right alongside the mathematical formulas to predict exact eclipses, literally the very same eclipses we still see tracking across our skies today.
Section 4. Historical Journey of Knowledge, Traveling the Silk Road and Beyond.
The timeline of the Surya Siddhanta reads like a grand epic of human intellect. Born around 400 CE, during the Gupta period, the tradition definitely didn't just die out. It was actively built upon by legendary mathematicians, like Brahmagupta around 628 CE. Then, by 800 CE, the genius of this text crossed borders. It was translated by Arab scholars, effectively bridging the knowledge gap, and eventually making its epic way into Europe. And around 1000 CE, the famous Persian scholar al-Biruni specifically praised this text during his extensive travels through India. We are talking about truly global science here.
Section 5. Immortal Legacy and Modern Use. The Living Legacy. The mathematical traditions that birthed the Surya Siddhanta eventually gave the world the concepts of zero, decimals, and advanced trigonometry. It fundamentally laid the foundation for modern astronomy as we know it. But even more amazingly, it is a living science, and this brilliantly illustrates that fact. The precise astronomical calculations from this 1,600-year-old text are still actively used today. All across India and the diaspora, people use this math to construct traditional punch-on calendars, which dictate exact dates, festivals, and timekeeping right now in the modern era.
Behind all the complex formulas, the sine and cosine tables, and the physical astronomical instruments, there was this incredibly profound philosophical driver. Jnanam Paraman Dhyayam. Knowledge is the ultimate goal. I think this quote perfectly captures the relentless, almost obsessive dedication of these ancient Indian astronomers, because they weren't just looking for practical tools, you know? They were driven by an unquenchable thirst to decode the fundamental truths of the universe itself.
You know, we so often view the progression of science as something strictly modern, right? Something born in just the last few centuries. But seeing the breathtaking complexity of the Surya Siddhanta, well, it challenges that view completely. It really makes you think, if this advanced mathematical and astronomical knowledge didn't exist 1,600 years ago, if it hadn't traveled the globe, shaping minds from the Arab world all the way to Europe, where exactly would our science be today?